Hello, welcome to this lecture. In this lecture, I'm going to explain about approach to measuring probability. In the previous videos, I already explained about counting techniques. Those are the addition rule, the multiplication rule, permutations, and combinations. Probabilities can be approached from several different conceptual perspectives. And there are four approaches for measuring probabilities. And these are the subjective approach, the classical approach, the frequentist approach, and the axiomatic approach. And in this video, I'm going to explain about three of these four approaches: the subjective approach, the classical approach, and the frequentist approach. And there will be another video about axiomatic approach. Let's discuss about subjective probability. As the name indicates, it is the degree of belief that outcome will occur. So it depends on the individual perspective or belief. As an example, we may say there is 50% chance that I will go to the party. Or if a doctor suggests about the condition of a patient, he or she may say there is a 70% chance that the patient has a bacterial infection. Another example can be an investor may believe that there is a 60% chance that a stock will increase in value over the next month. So what's the probability of the stock increase, which is 60%? Please note that different individuals may assign different probabilities to the same outcomes. And subjective probability is most of the time applied in decision theories and Bayesian statistics. So let's now come to the classical approach. This approach is a common one to calculate probabilities with the assumption of equally likely outcomes. So this approach assumes the outcomes are equally likely and the total number of outcomes is finite, which is n. So the formula is given as the probability of A is n of A divided by n of S, or the number of outcomes in A divided by the total number of outcomes. Let's consider this example. In a lottery, there are 100 tickets and only one ticket is the winning ticket. What is the probability that you will win if you buy one ticket? If you buy one ticket, which is n of A is 1, n of S is 100. So from the formula of classical approach, probability of A is equals to n of A divided by n of S. This is 1 divided by 100. So it will be 0.01. So this is the answer. Another example is the following. A fair die is tossed only once. What is the probability of getting one number 4? Number 2 is what is the probability of getting odd number? Number 3 is what is the probability of getting an even number? And the last question is what is the probability of getting number 8? So S is 1, 2, 3, 4, 5, 6. That is the sample space for tossing a die only once. So n of S is 6. Number 1 says, what is the probability of getting number 4? N of A is 1. Implies probability of A is N of A divided by N of S, and that is 1 divided by 6. That is 1/6 for the first one. Number 2 is the probability of getting an odd number. If A is odd number, it can be 1 or 3 or 5. This is an event, which is a subset of the sample space S. And so N of A here is 3, implies probability of A will be 3 divided by 6, because N of S is 6. This will be 1/2, so this is 0.5. Number 3 is, what is the probability of getting an even number? A, it can be 2 or 4 or 6. Implies N of A is 3 again. So probability of A will be N of A divided by N of S. So that is 3 divided by 6, also half, also 0.5. And the last question is, what is the probability of getting number 8? There is no number 8 in the sample space. So the event A in this case is empty set. Implies number of A will be 0. Implies probability of A will be 0 divided by 6, which is 0. So that is the answer. Let's also consider the following example. A box of 18 candles consists of 30 defectives and 50 non-defective candles. If 10 of those candles are selected at random, what is the probability? Number A, all will be defective. Number B, 6 will be non-defective. And number C, all will be non-defective. So we have how many candles? 80 candles. And we want to select 10. That is our sample space, that is N of S. But it says number of defective, we have 30 defective items, where number of non-defective items are 50, because this has to be 80 in total. And number A means all the 10 selected items are defective. N of A is select 10 of them from the 13 from the defective and 0 from the non-defective. This implies probability of A will be then N of A, which is 30 combination 10 times 50 combination 0 divided by 80 combination 10. So the result is 0.00001825. B is N of A will be 6R from the non-defective. So from the defective, select 4 because 4 plus 6 has to be 10. That's the number of events for A. We know the number of sample space N of S is 80 combination 10. So probability of A is 30 combination 4 times 50 combination 6 divided by 80 combination 10. And the result is 0.265. Okay, C is all are non-defective. So the number of the event A is from 30, 0, from 50, select 10 of them. This implies probability of A is equals to N of A divided by N of S, and that is 30 combination 0 times 50 combination 10 divided by 80 combination 10. And the result is 0.00624. And also, this is where combination is applied. Now let's discuss about the frequentist approach. The frequentist approach, in another way, we can also call it relative frequency probability or probability approach. And it is expressed similarly at the classical approach, but the concept is in here, there is a long run probability. So when there is very large sample size and when the experiment is repeated under the same condition many times, then we use the frequentist approach. And we use this formula, limit of N of A divided by N as N approach to infinity. Don't relate it to the calculus limit and don't try to substitute N with infinity. This expression is telling that the sample space is very large. So in that case, we use a frequentist approach. As an example, if records show that 16 out of 100,000 bulbs produced are defective, what is the probability of a newly produced bulb being defective? In here, what I have N of S is 100,000, and then N of A is 16 defectives. The probability of A is calculated as the limit of N of A over N as N approaches to infinity. We know that N is very large here. We can just substitute instead of N 100,000, and instead of N of A is 60. So this will be the 0.0006. Another example can be in a city with 500,000 drivers, there were 500 accidents last year. What is the probability of a driver being involved in an accident? So similarly, we have the following. N of S is 500,000 and N of A is 500. What is the probability of the driver involved in the accident? That is probability of A is the limit of N of A divided by N as n approach to infinity. So this is 500 divided by 500,000, and that is 0.001, which is 0.1%. So this is the answer. So yeah, these were the concepts to calculate probabilities using subjective probability, the classical approach, and the frequentist approach. If you have any question or suggestion, please put in the comments, and then I will get back to you. And thank you very much. And please share and like. Yeah, see you in the next video.